Hi dear students, today let us discuss the experiment number 3, figure of merit of galvanometer. Here we have a galvanometer. The amount of current required by the galvanometer to show unit deflection is called figure of merit of galvanometer. Coming to the principle of the experiment, deflection in a galvanometer is directly proportional to the current through the galvanometer. That means if current passing through the galvanometer is more, it shows more deflection. If current through the galvanometer will be less, then it shows less deflection. As we are observing the principle, it can be written that is I is proportional to theta and I is equals to K into theta, where K stands for figure of merit of galvanometer that we have to find in today's experiment. Coming to the formula, we have that formula K is equals to E divided by R plus G of theta. So first we have to add that R with the G and that sum must be multiplied with that theta, where E stands for EMF of the cell, R is the resistance which is to be connected in series with galvanometer, and G is the galvanometer resistance, theta that is deflection in the galvanometer. Yes, coming to the circuit diagram, it is one of the simple experiment where we are making use of the cell. So here we have the cell. The positive of the cell must be connected with positive of galvanometer, and from the positive end of galvanometer we must connect to the resistance box one end, that is S. The another end of S must be connected with the plug key K2. The free end of K2 is connected with negative of galvanometer. So from same negative end of the galvanometer we should connect that one to K1, and the other end of K1 must be connected with the high resistance value, that is R, and the negative of cell must be connected with that high resistance box, that is R. Coming to the apparatus, here we have a cell, galvanometer, and the resistance box. One must be taken as S, which is having lower value. The other one must be taken as R, which is having some higher value of resistance. So here we have two plug keys, K1 which is associated with R, and the another plug key K2 which is associated with S. Coming to the circuit connections, as you are observing here we have positive and negative ends of the cell. So from the positive end of a cell we must connect that to the positive of galvanometer. From the same positive end of galvanometer we must connect that to one end of resistance box S. The other end of resistance box must be connected to the plug key K2 one end. The other end of K2 is connected with the negative of galvanometer. From the same negative end of the galvanometer we are connecting that to one end of plug key K1. From the other end of K1 it is connected to one end of high resistance box, that is R, and this wire we are observing that is from the negative of the cell. Once again I am repeating the circuit connections. So positive of cell must be connected with the positive of galvanometer. From same positive end of the galvanometer we should connect to one end of resistance box S. The another end of resistance box S must be connected with the plug key K2. The another end of plug key K2 must be connected with the negative end of that galvanometer. From the same negative end of galvanometer we should connect that to one end of plug key K1. The free end of K1 must be connected with the high resistance box R, and the negative of cell should be connected with that high resistance, that is R. Then if you observe the tabular column, as we came to know earlier, by using multimeter we have to find that EMF of the battery or the cell. As we are observing the tabular column, first we have to find the resistance R in ohm, then deflection theta in divisions, S for theta by 2, and with the proper formulas we have to calculate G value and K value. Coming to the procedure how to perform the experiment. Yes, as we are observing here, galvanometer reads 0, and now initially we have to unplug some resistance from higher resistance value, that is R. So during this we have to keep that K1 closed. So now I am going to keep the key K1 closed, so it is showing the deflection out of range. So let us unplug some resistance. So here we have to unplug the resistance such that the galvanometer should show even deflection, that's it. Here there is no fixed value. Just we have to unplug the resistance such that we must get some even deflections like this. So the deflections we are observing, it is going to be gets varied. Yes, so somehow we have to adjust this for even deflection like this. Yes, somewhere we are getting, yes, deflection. Yes, so we got theta value as 20. So if we observe the resistance value, here it is, yes, 2500, 700, yes, 2800. So R value here we have to mention it as 2800. These are not fixed values. Just we have to observe the procedure and we have to follow the same steps. So we have to mention that R value. For R value, the corresponding theta, that is 20 divisions. So now after getting R value and theta value, now we have to get the S value. For this, we have to close the key K2 now. We can observe that the galvanometer, now it reads 0. So while measuring the value of S, both the keys K1 and K2, they are kept closed. Carefully we have to measure the value of S here, because many times we are going to be get confused. S for theta by 2 means what is the amount of resistance to be unplugged in that resistance box, so that deflection must be half deflection. That's why the aim only gives the half deflection method. So now initially we have that theta as 20, half deflection means we have to find the required S value to get the deflection value, that is 10. Let us observe the galvanometer as well as the resistance box. Yes, so I am going to unplug some value 100. It is near to 10, but still we have not got that exactly 10. So let us vary few ohms. So I am going to unplug some resistance. Yes, 20 ohm. Yes, now it's exactly reading the value of 10. So by half deflection method, if you observe the S value, it is 120. So that value here we have to mention, that is S is 120. Like this, we have to repeat the experimentation for several trials. For second trial, again, unplug the key K2. Already we have recorded the readings for these values. So let us change the R value. Again, we must get the even deflections. So let us change the R value. Like this, we have to get the even deflections, and again we have to measure the S value, and almost the S value remains same. If we observe the tabulations, some of the students have done the experiment and these are the values. For resistance R value 2000, they got the deflection as 28, and S value they got as 115. So by using the proper formulas, they calculated the resistance of galvanometer G value, and after finding G, they are supposed to find the K value. Yes, it is known that the K value should be in terms of microampere, and it is nearly 20 microamperes. So you have to repeat this for 3 trials, and finally you have to take the mean value, that is K is equals to figure of merit in trial 1 plus trial 2 plus trial 3 divided by 3. And finally we have to focus on the result, the resistance of the galvanometer, that is the average value of galvanometer resistance, and the figure of merit of pointer galvanometer. It could be in terms of microampere per division only. So that completes the experiment. Here care should be taken that we have to adjust the R value such that we must get even deflection, and almost the value of S remains the same. While measuring S, we must kept both the plug keys closed, but while measuring R, we have to keep K1 only closed, but while measuring S, we must keep both the keys to be in closed form. It is very important to focus on the unit also. Yes, we have to measure the galvanometer resistance, that is measured in ohm, and figure of merit of pointer galvanometer, that is measured in terms of ampere per division. Thank you. Sir.